Alright, so welcome back. We are now to the topic 1 of the GE114 satellite geodesy, which is the overview of the satellite geodesy. So this is for the authors and contributors and for the copyright notice. So I guess ako naman na na-discuss no during sa atong orientation. And here is the outline for this presentation of this topic. We have 3 parts. The part 1 is the background of and branches of geodesy. Part 2, the background of satellite geodesy, and lastly, the part 3, which is the historical development of satellite geodesy and its application. So this will be the intended learning outcomes, that after these lectures and exercises, you the student must have explained the concepts and principles of satellite geodesy, define the satellite geodesy, enumerate and define the different branches of geodesy, differentiate satellite geodesy from the other branches of geodesy, discuss a concise background of satellite geodesy, discuss the historical developments of satellite geodesy, and lastly, discuss the application of satellite geodesy. So let's start for the part 1, which is the background and branches of geodesy. Before we go to the proper definition of geodesy, there is a question that may arouse into our mind when we study about geodesy. This is, what is the real shape of the Earth? What if the Earth is this one, a perfect sphere? Or it might be this one, a hemisphere. Or what if the Earth is a pear shape? Or what if the Earth looks this one? And lastly, what if the Earth is this one? Siguro na yung mga hulog, no? If ever ka na ang atuang shape sa Earth. Well, that might be answered by you upon completing this subject. Next is, we are going to see, or we are going to discover now, that in our everyday living, geodesy is part of it. Example, are you familiar with this one? Yes, that's a Google Maps. Or, kisa na nga kadulaan Pokemon Go. No, sa mga Pokemon lovers diha. Or, are you familiar with this one? Yes, that's a satellite. Or, have you ever seen a person operating this kind of instrument? By the way, that is a GNSS receiver. Well, if you are familiar with those pictures, then geodesy is part of your everyday living. Another example is, have you experienced this one? Riding a bus. Of course, sa mga dili taga Butuan or outside Butuan City, or siguro tanan man siguro mo is sakay na aning bus na. So, as you can observe, there is a speed limit that was fixed by the company, the Bachelor Express, enable that the driver will be alarmed if the speed of the bus is exceed to the maximum level. Mo-alarm na siya sa driver that ang iyang speed DI is kusugra. So, that also serve as the monitoring by the company for those driver na mga abusado, no? Bisan og kanang gabi na kusog gyapon magpadagan. So, safety first ika nga. Or have you experienced this one or using this one? Maps.me or Google Maps. Labi na sa mga lugar na dili mo suhito or first time ninyo nakaadtuan nga lugar. So, mag-try man jud ta og look for another application or look for mapping application, enable us to become familiar kung aha dapit agihan ang street, aha padulong sa isa ka lugar. So that's it. And i-Grab, no? Application nga Grab. So this is a application to book taxis, labi na sa mga naamo sa metro cities like Cebu, Manila, and even Butuan City. Or basi na nakatry sa inyo diri o gamit ani Transeek. It's a local application that is for Butuan City, and this is discovered, or this is made by the students of Caraga State University. Transeek. Mura siya Grab, ang kalainan lang is sikad ang i-book, dili taxi. So again, if you are using those application, or if you have experienced those situation, then Geodesy is part now of your everyday living. It might be nga wala lang muna nabantayan, but yes, Geodesy exists. So for the proper definition of Geodesy, it means that Geodesy is one of the earth sciences, and it comes from the word Latin word Geodesia. Geo means earth, and the dien, which is to divide. In short, Geodesy is dividing the earth. There are other familiar earth sciences or geosciences, including na of course the Geodesy. So other earth sciences are geography. Geography, it describes what you find where on the earth. Like for example, land and water, the climate, the vegetation, and man's habitat in relation to this. Next, geosciences is geology, which is the study of the rock formations and its history. Next is geomorphology, which describes landforms and their evolutions. And lastly, the geophysics, which studies the physical forces that shape the earth. Geodesy is less well known, although it is the oldest of the geosciences compared to geology, geomorphology, geography, and the others. So what does Geodesy do? The following is an initiation into the mysteries of geodetic concepts. So Geodesy is centered on the three major topics, which consist of the size and shape of the earth, the gravity field of the earth, and lastly is per point positioning. Another technical definition of Geodesy is according to the classical definition of F.R. Helmert. According to him, Geodesy is the science of measurement and mapping of the Earth's surface. Another definition from the Geodetic Glossary or NGS 2009, Geodesy can be defined as the science that concerned with determining the size and shape of the Earth, or it is the science that locates position on the Earth and determines the Earth's gravity field. Another definition from Smith, that it is the science that determines the figure of the Earth and their interrelation of selected points on its surface by other direct or indirect techniques. It is a branch of applied mathematics that includes observation for determining the size and shape of the Earth and defining the coordinate system for three-dimensional positioning, the variation of phenomena near to or on the surface such as gravity, the tides, Earth rotation, crustal movement, and deflection of the plumb line. In other countries, specifically in European community, Geodesy is used as a term or umbrella term to describe all the activities like land valuation, land management, cartography or the art of map making, setting out surveys like Aztec surveys, route surveys, underground surveys like mine surveying, national mapping, boundary surveys or property surveys, land information systems, and all other activities except Geodesy in its tradition. So we have first branch, geometric geodesy. Its concern is the describing of location in terms of geometry. Consequently, coordinate systems are one of the primary products of geometrical geodesy. So the main output of this subject is the coordinate systems and determination of the locations in the specific point of the Earth. Next sub-branches is the physical geodesy. So this is the next subject that you are going to take up in geodesy, the physical geodesy. It concerned with determining of the Earth's gravity field, which is necessary for establishing heights. So the main output for physical geodesy is you are going to study about the different gravity fields and different heights para you can establish the z coordinate of the three-dimensional, which is the heights. Next is the satellite geodesy, the third subject that you are going to undertake in the geodesy subjects. It is concerned with the using of orbiting satellites to obtain data for geodetic purposes. So, from the word itself, satellite, satellite is the one that is artificially put in the outer space to observe the Earth. Observe the Earth. So, out from the orbiting satellites, we can communicate with them so that we can obtain data for our geodetic purposes, such as satellite images, and also for the determination of the exact location. Kanang ginagamit na GNSS receiver. So, si GNSS receiver, mo-communicate na siya sa satellites, and the satellites will give data to the GNSS receiver to give the exact location. So, another definition for branches of geodesy is from the Lopez, Sir Lopez of GAP Academy. So according to him, geometric geodesy is concerned with the definition of the Earth using the properties of an ellipsoid of revolution and other related geometric concepts. Physical geodesy, according to him, is a concern with the study of Earth's gravity field in order to determine its true size and shape. And for satellite geodesy, concerned with the using of satellite positioning systems in determining position and defining the Earth's size and shape. And according to Lopez, there is another branch of geodesy, which is the geodetic astronomy. So geodetic astronomy is concerned with the study of determining position using the measurements made by the observing celestial body. So kani si geodetic astronomy, it's a branch of geodesy nga deal siya on locating or determining locations of points in the surface of the Earth using the celestial bodies rather. So celestial bodies consist of stars, quasars, and other heavenly bodies. And we have also integrated geodesy. So it is a relatively new branch concerned with the unification of physical and geometric components of the Earth. So, there is an integrated geodesy, i-combine na si geometric o si physical. Positioning finds application also in the realm of hydrography, boundary demarcation, engineering projects, urban management, environmental management, geography, and plantology. The geokinematic finds application also in ecology. Thus, geodesy has a symbiotic relation with some other sciences. So we have a strong relation. We have here the strong relation of geodesy to other sciences. First is mathematics, which is the fundamentals, the physics, computer sciences, and we have also overlapping principles with other sciences such as geophysics, which is the study of global gravity field. So ni overlap siya ka, it's because in geodesy we have physical geodesy which deal more on the Earth's gravity field. And in fact, the blurred boundary between these two sciences, the geophysics and geodesy. And we have also here the weak relation to other sciences. We have space science, the astronomy, oceanography, atmospheric sciences, geology, and etc. So here is the illustration of geodesy and its relationship with other sciences. As you can see, The computer science, physics, and mathematics, which is the fundamentals, is the root. No? And the output of these three sciences can be a mapping, urban management, engineering projects, boundary demarcation, ecology, environmental management, geography, plantology, and hydrography. And also, it has a interchange or related sciences such as the geology, atmospheric science, astronomy, geophysics, space science, and oceanography. So we are now in the part 2, which is the background of satellite geodesy. So first, ato sang define what is a satellite. When we say satellite, it is an object moving a curved path around a larger object. So in general term, kung moingon tag satellite, mo na siya ang isa ka object nga nag-revolve or nag-rotate or revolve, no? Revolve ang right nga term. So nag-revolve sa isa ka object which is larger than sa iyaha. So moon is one of the original, no, and natural satellite. So ang earth is na may isa ka moon, no? So ang moon is considered as a natural satellite. And nowadays there are many man-made, no? Man-made or kanang gitawag nato siya og artificial satellites. Artificial kay it's because it's man-made, no? Binuhat naman siya sa tao. And for the definition of satellite geodesy, so balik ta sa definition first ato sang himayon, no? Ang geodesy nga definition. So the classical definition according to Helmert, no, geodesy is the science of the measurement and mapping of the Earth's surface. And this definition includes the determination of the terrestrial external gravity field as well as the surface of the ocean floor. So, may tag geodesy, it's broad na siya, no? Broad na siya nga definition na nag-say si geodesy is a science of measurement and mapping the Earth's surface. That includes the external gravity field, external terrestrial. And satellite geodesy comprises the observational and computational techniques which allow the solution of geodetic problems by the use of precise measurements to, from, or between the artificial or mostly near Earth satellites. So, sabtan naman siya, no? Satellite, nag-consist siya of computational. So, computational based on the satellites na nag-revolve, no, around the Earth to address, no, some geodetic problems or to have a solution, no, of geodetic problems in a precise measurement. Another one, satellite geodesy is the measurement of the form of dimensions of the Earth, the location of objects and its surface, and the figure of the Earth's gravity field by means of artificial satellite techniques. So basically, satellite geodesy is mapping or measuring, no, the Earth's features, pati na ang Earth's gravity field, its form, its size, its shape, by use of the artificial satellite, by observing, no, observing artificial satellite nga naa sa beyond na, no, sa ato ang atmosphere. It belongs to the broader field of space geodesy. Si satellite geodesy daw is nasulod siya, no, sa broader nga term which is ang space geodesy, which also includes such techniques as geodetic, very long baseline interferometry or kita nang gitawag na itong VLBI, and lunar, no, laser ranging. So traditional astronomical geodesy is not commonly considered as part of the satellite geodesy, although there is a considerable overlap between these techniques. Kay sa una class, wala pa ang satellite, wala pa na-discover ang mga satellites. Ang pamaagi, no, is ang astronomical observation or kanang gitawag na itong astronomical geodesy, astronomical geodesy. So same lang gyapon sila concept, measurement lang gihapon, defining the locations, mapping the Earth's surface, but dili siya si astronomical geodesy is dili siya sulod sa satellite geodesy. though same sila or nag-overlap sila sa ilahang techniques or parehas lang jud sila. So the main goals of the satellite geodesy are, no? First is to determine the figure of the Earth, positioning, and navigation. Second is to determination of the geoid, Earth's gravity field, and its temporal variations. And lastly, the measurement of geodynamical phenomena such as crustal dynamics and polar motion. So tulo ka goal, no? First is ang positioning and navigation, location, to be exact. And second is the determination of geoid or the Earth's gravity field. Output ani niya class is kanang heights. And lastly is the measurement of geodynamical phenomena such as crustal dynamics, pag-iswag, no? Pag-iswag sa crust. Okay. We all know nga the continents or naman tagitawag ng tectonic plates, di ba? Sa atong geology. So, ang kana siya nga tectonic plates is na siya yung movement. So, out from that, no, gina-monitor na siya sa through satellites. No? Of course, kana pong bagyo, no? So, weather conditions, polar motions. So, ang pagyuntag polar motions, ang iswag, no? Ang pag-iswag sa ato ang poles. Alright, so satellite geodetic data and methods can be applied to diverse fields such as navigation, hydrography, oceanography, and geophysics. So, ang output basically sa geodetic satellite geodesy, of course, with proper methods and processing, so can be used in the navigation such as air navigation, ocean navigation, or sea navigation, and in hydrography, no, the measurement or the science and measurement of the water bodies. Oceanography, which is the study of oceans, and geophysics. And satellite geodesy relies heavily on orbital mechanics. It's because si satellite is mag-orbit magina siya, no, sa Earth. So we need to understand, no, the whole concept of how the orbits, no, behave, or how the what are the movement, no, of the orbits or the mechanics as a whole, no, as a mechanics as a whole. And satellite geodesy comprises the observational and computational techniques which allow the solution of geodetic problems by the use of precise measurements to, from, or between the artificial, mostly near-Earth satellites. And consequently, satellite geodesy belongs to the domain of basic sciences. Si satellite geodesy daw, sulod siya sa basic sciences. And on the other hand, when satellite observation are used for solving various problems, satellite geodesy can be assigned to the field of applied sciences. Basically, no, si satellite geodesy sulod siya sa basic sciences, but the observation daw is gamiton siya for various solving problems, so mahimo na pud siyang applied sciences. So versatile si satellite geodesy. And considering the nature of the problems, satellite geodesy belongs equally to geosciences and to the engineering sciences. Okay, since application man siya, so masulod siya sa engineering sciences and geosciences. And by virtue of their increasing accuracy and speed, the methods are resolved to satellite geodesy are used more on the disciplines like geophysics, no, and oceanography and navigations, and they form an integral part of geoinformatics. So, din yung geoinformatics class. So, geoinformatics is the science and technology dealing with the structure of and character of spatial information. So, again, pag mo yung spatial information, is the three-dimensional aspect, no, sa Earth. The X, Y, and Z. No? It's capture the classification and qualification, storage and processing, and dissemination, including the infrastructure necessary to secure optimal use of the information. So, sa geoinformatics as a whole is the science and technology da kuno nga i-characterize niya ang spatial information such as the locations, dini-integrate, and i-classify, and i-store, i-process pa jud. And out of that processing and different techniques of methods, so i-portray siya by the use of maps, no, or infographics, and i-disseminate for the information of everyone. So mo na siya ang meaning sa geoinformatics. And satellite geodesy, no, start daw siya, nag-start ang evolution sa satellite geodesy is when the first artificial satellite was launched, no. So ang tawag ato nga satellite si Sputnik 1, no? And that was on October 4, 1957. So satellite geodesy has developed into self-contained field in geodetic teaching and research, no. Kay since pag-launch man kibali sa satellite is ang iya man yung major na function is to locate some point or specific point on the earth by the use of satellites. So pang geodetic jud siya, so geodetic teaching and for the some research, no, with close relation with the interaction of adjacent fields such as the geodetic astronomy, no, which is the determination of the geodetic positions by the use of the stars and quasars, no, na gitawag na gravimetry, which is ang output niya is ang physical geodesy or the physical surfaces, and the mathematical geodesy, terrestrial geodesy and observations. Then the assignments and contents are due to the historical development. So there are two methods, no, in the satellite geodesy. First is ang geometrical method. So geometrical method is also called as the direct method. So from the word itself, direct, no, from the satellite, one satellite, no, kani si isa ka satellite. So out from that information data nga pwede niya mahatag, it can mahatag niya directly, no, directly sa mga points. Okay, syempre kani is ang point 1, 2, 3 for example are the known points of the earth, and out from that information of point 1, 2, and 3, so makuha po niya ang information sa new station which is ang gusto nimo i-establish. So that's what we call direct information. Isa lang ka satellite, no? From the satellite, hatag og data sa mga points to determine the other or the new station. So because the particular position of the satellite enters directly into solution, so muna gitawag siyang direct method. The other one is the dynamical, no? Dynamical method of geodesy. So ang iyang concept, no, from the new station, there are many satellites, no, ang i-consider niya. So that's the nearly the concept of the satellite geodesy. From there na ay mga points nga known, no, points nga known, di-triangulate niya, and out from the triangulation na processing, so mahatag niya ang coordinate sa new station. So kibali from there, no, si satellite, so nag-orbit siya, naghahatag pud siya points ana sa new nga station, location location sa new nga station which ang gusto niyo makuhaon from the points nga known, no, which is gikuha pud sa other satellites and gi-transmit padulong sa isa ka satellite. So dynamical method is also the indirect method. It's because dili ang katong satellite nga sa kung giyon pa ganina, ang katong satellite nga naghatag og data sa satellite or nag-determine sa location sa new station is dili siya mao ang satellite pod, dili the same satellite ang nag-acquire pod sa mga known points, no, nag-acquire of information from the known points, like for example point 1, 2, 3 and 4. So we transmit lang yung information, then give the information to the new station. So because the required parameters are determined implicitly from the orbital behavior of these satellites. So a further classification of two of the observation techniques refers to the relation between the observation platform and the target platform. So mao jud ni ang the whole concept sa satellite geodesy, no. Sa taas is na observation platform, i-transmit ang data into the target platform which is ang kanang points. No? For example, si satellite, no, muna siya ang observation platform, and kanang mga GNSS receiver or the target platform para makakuha siya og location at that specific location. There are another methods, no, in satellite geodesy, which is ang kanang gitawag na tong earth to space methods. No? Kani si earth to space method, direction from the camera observation for example, and nato gitawag po nga satellite laser ranging or SLR, and Doppler positioning, example C, transit or Doris, and geodetic use of global positioning systems. Earth to space, for example, kanang GNSS receivers, no? GNSS receivers, so pag imo na siyang i-start, mo-transmit na siya padulong sa satellites above, no? Ang satellite above, no? To have a connections or signals para makahatag siya og katong pag ma-range na to niya ang satellite above, then maka-transfer na siya og data to have a information or location na inyong gusto ma-acquire. And another method is aning baliktad na pud siya, no? From the space to earth na pud siya nga method. Tawag na siya radar, altimetry, and spaceborne lasers, and satellite gradiometry. So, like for example, remote sensing images, no? From the satellite, di-capture niya, no? Images sa earth, which is ang target niya is ang earth surface from the satellite above, or kanang itawag nato nga digital train models, no? From the satellite synthetic aperture radar, no? Ranging. So ang output niya merely is ang kanang DTMs or DSMs. So out from the space vehicles or space satellites, target niya sa earth to have a information. And lastly is ang space to space method rather. So ang tracking ani niya is ang satellite to satellite. So from isa ka satellite, ipasa niya ang information or data sa isa ka satellite. So para naslay what I mean is communications between two satellites na pwede sila makahatag og data, no? Maka-transfer og data from satellite to satellite. Alright, so I guess this ends this video lecture, no, in GE 114 satellite geodesy, and this consists of the part 1 and part 2 of this topic, and stay tuned for the more upcoming videos. Keep safe everyone, and have a good day.